Okay, so I want to talk a little bit about finance, banking, investment, credit cards, or interest rates, and this formula that you see all the time in math classes, which is A is equal to P times 1 plus R over N to the NT. This is one of the formulas that has the most letters in all of math, I think. And so it's just important to remember that A is the amount. So usually when you're given these problems, you'll be asked to find what the amount some principal grows to. And principal in finance is a term that measures how much you start with. So principal is kind of like if you have a piece of money, there's a lot of times principal and interest in it involved in it. Principal is the part that when you strip the interest rate out of it. So this part is interest rate. N is, well, T is easier than N. T is time, and it's almost always in years. And N is compounding frequency. And I'm assuming this is more of a review type video than a learn it from scratch thing. So I'm not going to go in depth into all those things, but I just say, let's say you have 12% interest rate and it's compounding quarterly and my time is equal to 3 years and let's say P is equal to $300, then it would just say the amount is equal to 300 times 1 plus 0.12 divided by 4 raised to the 12th power. And then notice, I think you should also notice that this part right here gets multiplied by the 300. So you can sort of think of this part alone as a multiplier. And then sometimes you might get, the question might get flipped around on you to say like, oh, say I want to have $20,000 ready for college 5 years from now so that I can pay for it. It's even probably going to be more expensive than that by the time I get there. But I want to know exactly how much I need at a certain date in the future. And I want to use that to tell me how much I need to invest today. And then that just becomes A divided by 1 plus R over N raised to the NT is equal to P. Okay, so that's when the question gets reversed. That's how you do it. Now I want to go through a hypothetical example because I think it's an important one to understand this this thing that comes up in math is going to come up a lot of times in the future math. And so this example, now we've done a lot of times with credit cards where you're borrowing money, but now let's flip the view around a little bit and let's say you're saving money or you're investing money and you found this place. It's a bank and it says it's going to give you a 100% interest rate. And you're like, that is really good. So I'm going to invest my money there. But they're like, but the catch is you can only invest $1. And you're like, all right, well, I'm going to invest $1 because I can't get I can't even get 5% anywhere else. So I might as well take my $1 and put it in that bank account and get 100% out of it. And then you're like, by the way, how often does it compound? And they say, oh, annually. Okay, so I think if it compounds annually, you can kind of think, what is this 1 plus 1, which equals 2? I'm going to have $2 at the end of the year. However, luckily, you have a friend, and you have a friend that works at this bank, and you have influence over this friend. And while this may not be an ethical thing to do, you do it anyways. You say, buddy, will you just make that compound semi-annually because it'll make me some more money? And your buddy says, yeah, I can do that. And so I'm going to change N is equal to 2. Okay. And so if N is equal to 2, you might say, will I have more money or will I have less money at the end of the year? Well, you may know by now that the more frequent they compound, the quicker the investment grows, or the quicker your debt will grow if it's on the other side. So by how much, what will 100% rate of return separated evenly over two 6-month periods is going to be 1.5 squared. And 1.5 squared is $2.25. And you're like, all right, I just got an extra 25 cents. However, you could go back and say, look, guy, 2 times is not that many times to be compounding. And I want you to do it more often, because what bank out there doesn't compound at least quarterly? And so he says, okay, I'll do it. And if you try to think of how much are you going to have if you get a 100% interest rate 4 times per year, you're going to get 25%. So it's 1.25 raised to the fourth, or let's see what this is. This is 1.25 raised to the fourth, and I get $2.44. And then you might be like, all right, well, actually, how about I get, what's another good n to measure? Well, let's say 12. What would 12 be? If I'm going to do 12, I'm going to have 1 plus 1 divided by 12. 100% is just 1 raised to the 12th power. And I can start, I'm starting to see where this is going now, so I'm going to build it's really like I'm building something, but I'm going to enter in something that allows me to adjust that compounding frequency formulaically. So I'm going to add a slider for n. Let's make it go from 1 to 100. And I'll go a step size of 1. And when I move it notice when I move it to 3, it's 237. If you notice the progression, it goes up by 25 cents. It goes up by 12 more cents. It goes up by 7 cents. It goes up by 4 cents. It goes up by about 4. It's going up, but it's going up by less and less each time. So if I look at this is 2.61. And another way you see this in the table is this is plus 1. This is plus 25. This is plus 2. This is plus 19. So you can already see it's starting to grow out. Even when x is going up by more and more each time, y is going up by less and less each time. I think this is 17. Okay. And these are 0.25, 0.19, 0.17. And so you're like, all right, well, this is cool, buddy. I'll just keep going as high as you can get. And the question is, do you expect it to keep raising forever and ever and ever? Or is there some limit to how much that $1 is, as much influence as your friend has? What's the most money you could get out of that dollar that you invest? And so that is effectively raising this n as high as it possibly can. If you watch what happens, it's leveling out. It's not getting that much higher. Okay. If I'm at 100, it's at 2.70. If I maybe make this go, let's go from 10 to 10,000, and let's make the step by 100. Then notice that it's going up by less and less and less. It's reaching its limit. And that limit is this new letter that you're going to see in your math class that's called E. Okay. And E, if we want to think of what is E equal to, it's 1 plus 1 over n raised to the n, sort of. I need one more statement in there. It's the limit as n goes to infinity. And the way that affects problems that have to do with interest rates and growth is now you'll see continuous somewhere in the statement, probably in the problem, continuous compounding. So if I go back up to this example and I changed it from n is continuous, you could think of this as a is equal to 300 times the limit, because infinity doesn't really exist, so we have to use limit statements. Limit as n goes to infinity of 1 plus 0.12 over n raised to the 3 times n, which I could say limit is a equal to 300 times. Now here's what I'm going to do. I'm going to change this so I have limit as n goes to infinity of 1 plus 0.12 over 0.12 n. Anyways, the formula ends up becoming A is equal to P times E to the RT, which would be A is equal to 300 times E to the 0.12 times 3. And that's all you have to know about it. I fumbled a little bit trying to show you how it turns into that. So I'll have to go back to the drawing board a little bit. However, this is the formula that you need to know when it's continuous. I still have some work to do on my own teaching and learning, but for the foreseeable future, you should be prepared to answer those types of questions.